You're in the kitchen, reaching for a glass, when something skitters across the counter. 6 legs. Maybe 8. Too fast to count. Your hand recoils before your brain has even finished the sentence. What is that? Your heart is already pounding. Your skin is already crawling. And here's the strange part. You probably didn't decide to feel any of that. It happened to you. Faster than thought. Faster than choice. That gap, the space between seeing the bug and screaming about the bug, is where this story lives. Because somewhere in that gap is a very old machine, built by evolution, running code you never wrote and can't switch off. And by the end of this, you're going to understand exactly why that machine exists, why it misfires so badly on something as harmless as a beetle, and why the very thing that makes insects hard to look at is the same thing that once helped keep you alive. Let's start with the obvious answer, the one everyone reaches for first. Insects are dangerous, so we evolved to fear them. Simple, tidy, almost certainly wrong, or at least radically incomplete. Here's the problem with that story. Most insects that trigger a full-body recoil and you have never hurt a human being in their life. A house centipede cannot hurt you. A silverfish cannot hurt you. A daddy longlegs, despite the myth, barely has venom potent enough to bother a fruit fly. Yet people scream, flinch, and sometimes cannot sleep in a room after spotting one. Meanwhile, the animals that actually kill the most humans on Earth barely register as scary to most people at all. Mosquitoes cause more human deaths per year than any other animal alive, spreading malaria, dengue, and other diseases to hundreds of millions of people. And yet almost nobody has nightmares about mosquitoes. We swat them without a second thought. If fear tracked danger, that ranking would be reversed. So danger alone doesn't explain it. Something else is going on. And to find it, you have to stop asking what could hurt me and start asking a stranger question. What does my brain think it's protecting me from? To answer that, picture your brain not as one system, but as a building with different departments, each optimized for a different kind of threat, each built at a different point in your evolutionary history. There's a floor built for physical danger, the department that reacts to heights, to sudden loud noises, to things that could crush or bite or fall on you. That's fear in the classic sense. But there's a separate floor, older in some ways, built for a different enemy entirely, contamination. Disease. Rot. The Department of Disgust. Psychologist Graham Davey, who studies the structure of animal fear at the University of Sussex, found something revealing when he asked people to rate how disgusting versus how dangerous different animals felt to them. Predators like lions and sharks scored high on danger, low on disgust. But small creatures with many legs, an irregular scuttling gait, and no clear face, spiders, cockroaches, maggots, most insects, scored low on danger and startlingly high on disgust. Your recoil at the kitchen counter wasn't your danger department firing. It was your disgust department, and disgust runs a completely different program than fear does. Fear tells you, get away, this could kill you. Disgust tells you something quieter and stranger. Don't touch that, it could get inside you. That distinction matters more than it sounds like it should, because disgust evolved to solve one of the oldest problems a body can face, not predators, but pathogens. Long before humans worried about lions, our ancestors were surrounded by an invisible war against bacteria, parasites, and rot, and natural selection couldn't give them microscopes to see the threat. So it gave them something cruder and faster, a set of visual triggers that flagged anything statistically associated with disease and made contact with it feel repulsive before any reasoning was involved. Researcher Valerie Curtis, who has spent much of her career at the London School of Hygiene and Tropical Medicine studying the evolutionary roots of disgust, mapped out which images across cultures reliably provoke that same wave of revulsion. And the list reads like a catalog of infection risk. Body fluids, spoiled food, wounds, things that move erratically, in swarms, in ways healthy bodies don't move. Insects check almost every one of those boxes at once. They cluster. They emerge from rot, from carcasses, garbage, decaying wood. Many species genuinely do carry disease, and their legs move in patterns that no vertebrate body produces, which your visual system reads not as different animal, but as wrong, in a way that feels almost physically uncanny. That's the reveal, and it's worth sitting with for a second, because it reframes the whole mystery. You're not afraid of insects because they're dangerous predators. You're disgusted by insects because your ancestors' immune system had an ally it never asked for, a mental one, running in the background, treating certain shapes and movements as biohazard warnings millions of years before anyone understood what a biohazard was. But that still leaves a gap. Disgust explains the flinch, the get it away from me. It doesn't fully explain the screaming, the panic, the inability to be in the same room. For that, you need to understand how fast this whole system operates, and how little say your conscious mind actually gets. In 2001, psychologists Arne Oman and Susan Manica, working out of Karolinska Institute, proposed something they called the fear module, a dedicated, evolutionarily old circuit in the brain that can detect certain threat-shaped stimuli and trigger a bodily response before the visual cortex has even finished building a complete picture of what's being looked at. Their experiments showed that people spot images of spiders and snakes embedded in a grid of neutral objects faster than they spot flowers or mushrooms in the same grid, and that this speed advantage survives even when the stimulus is flashed too quickly for conscious recognition. Your amygdala, the brain's threat alarm center, gets a rough sketch of the scene and can launch a full-body response before the rest of your brain has confirmed there's anything to respond to. This is the part that explains why reasoning doesn't help in the moment. You can know, intellectually, with total certainty, that the spider on your ceiling is a harmless house spider. That knowledge lives in your prefrontal cortex, the newest, slowest part of the system. But your amygdala already fired half a second before your prefrontal cortex even opened the file. By the time logic shows up to the meeting, your heart rate is already elevated and your hand has already pulled back. You're not choosing to be afraid. You're being informed, after the fact, that you already were. And this is where the story takes its strangest turn, because this system isn't just old, it's deliberately, almost comically, overcautious. Evolutionary biologist Randolph Ness described this design principle with an analogy that's stuck for decades. Think of your threat detection system like a smoke detector. A smoke detector that only ever goes off during real fires, and never once during burnt toast, is actually a badly calibrated smoke detector, because the one time it fails to catch a real fire, you die. So evolution didn't build a system optimized for accuracy. It built one optimized for cheap false alarms, because 1,000 unnecessary flinches cost almost nothing, while one missed threat could end a lineage. Your disgust toward a totally harmless beetle isn't a bug in that system. It's the system working exactly as intended, erring deliberately and permanently on the side of paranoia. Once you see it this way, something interesting happens. The fear stops looking irrational and starts looking almost like an heirloom. A slightly overtuned smoke detector that your ancestors needed and that you inherited unchanged, because there was never enough evolutionary pressure to dial it back down. Modern life doesn't punish you for flinching at a spider the way ancient life would have punished you for ignoring a real threat. So the trait just stays. Unedited. Passed down like a family recipe nobody thought to update. That inheritance also explains one of the strangest wrinkles in insect fear. It's not evenly distributed, and it's not fixed at birth. Studies on children have found that infants don't show a startle response to spiders or insects, but they do show enhanced attention toward them. Looking longer, tracking them more closely than they track neutral objects, as if some early warning circuitry is already primed to watch this category closely, waiting for social or experiential input to decide whether watch closely should escalate into be afraid. That input often comes from a single event, a parent's flinch, one bad encounter, one movie image, and the fear can lock in almost instantly, then persist for decades, resistant to logic in a way that few other fears are. This is what researchers mean when they talk about biologically prepared learning. Not that you're born afraid of insects, but that you're born extraordinarily easy to teach that fear, in a way you're not equally easy to teach to fear electrical outlets, which are statistically far more dangerous to a toddler than any beetle will ever be. And that's the detail that should genuinely surprise you. Your brain isn't calibrated to real-world risk at all. It's calibrated to ancestral risk, filtered through categories. Erratic multi-legged movement, association with decay, unpredictable swarming. That made sense on the savannah and make almost no sense in your kitchen. You are running threat software designed for a world that mostly no longer exists, applied to a world where the actual dangers, cars, pathogens spread by handshake, blue light at 2 a.m. Don't trip the alarm at all, because they don't look the part. The wiring wasn't built to be accurate. It was built to be fast and cheap and rarely fatal to ignore. Which brings you back to that kitchen counter, that skittering shape, that half second of pure animal recoil before your thinking brain even clocks in for the day. You now know what that half second actually is. It's not proof that the thing in front of you is dangerous. It's a signal flare lit by a very old, very anxious ancestor, still standing guard inside you, still watching for rot and swarm and wrongness the same way it did 100,000 years ago, utterly unaware that the world changed, and that you, mostly, are safe. So the next time something small and many-legged sends your whole body lurching backward before you've even decided to move, you won't just feel afraid. You'll recognize the feeling for what it actually is. Not a warning about the bug in front of you, but a message from every ancestor who survived long enough to become you. A message that arrived too fast for words, saying, simply, still here, still watching, still doing its job.